Hello, I'm Katie Malcolm, an instructional consultant at the University of Washington Center for Teaching and Learning, which is a partner of the Waseda University Center for Teaching, Learning, and Technology. I'm here today on Zoom with my colleagues from the University of Washington and Waseda University to ask them about how the principle of developing mastery has helped you understand your students and their learning.
I started teaching first-year college chemistry about 2 weeks after receiving my PhD in computational chemistry. I didn't have any formal training in teaching when I started. All I had was a passion to do right by my students. As a result, though, I definitely had an expert blind spot about chemistry, and it was really a struggle to connect with my students. I did the best that I could, but I know that I inadvertently omitted crucial steps and skills when I was explaining certain concepts. However, I did start to notice when a student was clearly not understanding something that I was saying, even if they were trying to pretend like they did to save face. When I noticed that, especially during office hours, I wouldn't just move on. I would ask the student where I'd lost them and essentially invite them to collaborate with me in helping them to put the pieces together. I made sure to use language that was as non-judgmental as possible and tried to make it clear that there was absolutely nothing wrong with admitting to being lost and that I would not leave them behind. Through numerous interactions like this, my expert blind spot became a little smaller, although I know that it is still there even today. I learned a lot from my students in those early days about how to talk to them in a way that's not accidentally alienating. And these interactions with students also started to impact how I constructed assignments. Early on, I would assign complex problems without much in the way of step-by-step instructions. My thinking was that the students would be better off if they developed a solution path entirely on their own. But I didn't really realize how cognitively challenging it was for them to do something like this as novice learners. So nowadays, I make sure to scaffold individual problems and assignments to lead the students from one cognitive step to the next in a rational way.
In Japan, we have a type of seminar system that helps students develop mastery. It is a traditional teaching and learning style based on apprenticeships and peer interaction. In science and engineering fields, the seminar is called a lab. And humanities subject, it is called a zemi. A lab and zemi is constructed by one or more professors based on their expertise. Starting in their junior year, so novice learners can participate in the zemi led by the senior and graduate students. In the zemi or lab, seniors teach younger students about the different components of research. For example, how to find the research questions, develop a methodology, facilitate a discussion, give a presentation, and write papers. Additionally, in the science lab, seniors teach the new students how to operate equipment and how to perform experiments by a demonstration. They teach the implicit knowledge so that students can learn by practice. My lab is for educational technology research, for instance, developing learning content, tools, and systems. My students need to learn basic knowledge of teaching and learning, skills such as programming, content creation, experimental design, statistical analysis, and so on. According to the stages in the development of mastery, we professors might be at stage 4, unconscious competence level. But undergraduate students are mostly like at stage 1, unconscious incompetence level. In my case, it is very difficult for me to determine the points that students need to learn and what I need to teach them, since we are at such different stage of mastery. However, graduate students may be at stage 2, conscious incompetence, or stage 3, conscious competence. So they can facilitate the learning of component skills from each other and to practice together in the lab. Furthermore, it is easier for the graduate students to facilitate the undergraduate learning since they are closer together on the mastery spectrum. This helps me scaffold learning of the content and the skills needed to do work in my lab. I designed my lab around different research projects with research teams that have both undergraduate and graduate students. I do not teach a lot, but lead the integration of their skills instead. Undergraduate students first learn the skill set in the lab. That is the near context and will apply the skills to other things they are interested in. Then the students will transfer the knowledge in a far context in graduate school level. My lab is open for my students to use anytime, and we have discussions outside of regular classes. Throughout our daily discussion, I give students a lot of new ideas for them to continue their future work. Sometimes we even talk until midnight.
When I teach writing courses, I find that the idea of integration is particularly helpful for understanding why some students who consider themselves to have a mastery of English writing can still produce writing that's totally incoherent the first time that they have to write an essay for my class. As Ambrose et al. Mentioned, our performance on tasks tends to degrade when we have to concentrate on more than one task at a time, and the cognitive load or the demands on our brains can often exceed what our brains are capable of processing at one time. So the more complex a task becomes, the more of a cognitive load it creates. And the more complex or unfamiliar a particular topic is, the more likely my students are to struggle to write about it. This explains why students are more likely to produce bad or less coherent writing when they're writing about a deeply complex text or a topic. The cognitive load of critical thinking and writing and even reading makes the task become exponentially more difficult. Therefore, when they're concentrating on critical thinking, students are more likely to produce writing that is less coherent or contains lots of typos and other mistakes. Our brains can only focus on so much at once. Sometimes I hear from students that they're frustrated that they are becoming worse writers in my class. I let them know that this isn't the case. It's just that their brains are processing a lot of new things at one time. So I reduce the cognitive load for them by asking them to write a brainstorm draft, where they just develop all of their ideas first, concentrate on the critical thinking, and then worry about the grammar or other aspects of the language in a later draft. Then after their ideas are developed in that brainstorm draft, I ask students to focus on revising the language in their paper for more coherence, clarity, and eloquence.